everyone, and welcome to one of Soil 4683 or Soil 5683's reference videos. The topic for this video is going to be on significant figures. Significant figures are specific digits that help convey the reliability of a certain quantity. What this basically means is that we want the answers we give to be as thorough as possible, while also being concise so that we can convey an accurate portrayal of the specific measurement. Throughout the course, significant figures are essential for the problem sets and the test to prepare students for real-life expectations. So we will be going over examples to make the rules a little clearer. There are 6 main rules that help us understand significant figures. The first 4 rules have to do with zeros. Rule number 1 states that non-zero digits are always significant. Rule number 2 states that leading zeros are never significant. The third rule is that embedded or sandwiched zeros are always significant. And the last zeros rule is that trailing zeros are only significant if the decimal point is specified. Let's look at some examples to understand the concepts. When we look at example number 1, we see 0.0049. Looking at rule number 1, we know that non-zero digits are always significant, so we definitely have 2 significant digits in this number. But rule number 2 tells us that leading zeros are never significant. So the first 4 zeros here are not significant, which means total significant digits for the first example is 2. Looking at example number 2, we see 0.0324. 324 are all non-zero digits. However, the zeros in the front are leading, so they are not significant numbers, leaving us with only 3 significant figures here. Rule number 3 states that embedded zeros are always significant. If we look at example number 3, we see 3091. There are 3 non-zero digits, and this zero happens to be between 2 non-zero digits. That means that this example has 4 significant figures. Example number 4 is 5.00603. We have 3 non-zero digits and 3 zero digits, but these zeros are embedded or sandwiched between the 5 and 6 and the 6 and 3, leaving us with 6 total significant figures for this example. For the last rule, trailing zeros are significant only if the decimal point is specified. When we look at 83,000, there is no decimal point specified, so the number of significant digits for this number is 2. However, when we look at 83,000 here, we can see that there is a specified decimal point, which means that these zeros are now significant, leaving us with 5 significant figures. For this example, we have 83. We have trailing zeros are significant because this decimal point is specified right here, leaving us with, again, 5 significant figures. The 5th rule states that the last digit retained is set by the first doubtful digit. This is for addition and subtraction. It doesn't make a lot of sense right now, so let's look at some examples to help clear up any confusion. For example number 1, we have 13.0198 plus 1.2 equals 14.2198. Now, this says that the last digit retained is set by the first doubtful digit. What doubtful digit means is that, as we can see, 1.2 doesn't go past the 10th decimal place. So we don't want our final answer to go past the 10th decimal place either, because it's doubtful that we know what's actually going on past 1.2. So what we can do is draw a line right where 1.2 is. So we know we want our final answer to be within this limit right here. So when we look at the number next to our 2, it's 1, so we know we're not rounding up. And our final answer that we want to put down is 14.2. The same can be said for subtraction. When we look at this example right here, we see 59.21 minus 18.8722, leaving us with 40.3378. Looking at our first doubtful digit, we see that 59.21 doesn't go past the 100th decimal place. So we don't want our final answer to go past that either. So let's draw a line. And we see that we're left with 40.33. However, since this 3, the number next to it, is 7, we're going to end up rounding up, leaving us with the final answer of 40.33 4. Our last rule has to do with multiplication and division. It states that the answer can contain no more significant figures than the least accurately known number. Let's look at some equations to make it more understandable. When we look at 307 times 32,000, we get an answer of 9,824,000. However, when we look at our first two variables, we see that 307 has 3 significant figures due to the embedded zeros rule. 32,000, however, only has 2. So we don't want to have any more than 2 significant figures in our final answer. That leaves us with 9,800,000 as our final answer. For example, number 2, we have 480 divided by 23,000, leaving us with a very small number. 480 has 5 significant figures because we have a specified decimal, while 23,000 only has 2. So we want to make sure our final answer only has 2 significant figures, leaving us with 0.021 due to the leading zeros rule. Thank you.